Welcome to another exciting educational video brought to you by Chrysolite Tutors. Um, we'll be looking at EDU 821 statistical method, and we'll look at the unit 1 of this particular course. It's meant for education students for the National Open University. The topic for the discussion today is the nature of data and scientific observations. The nature of data and scientific observations. So at the end of this unit, you'll be able to define statistical data and statistics. Number 2, you're able to conceptualize how data are derived from narrative, description, or information. And number 3 objective is that you'll be able to state the purpose of statistics and statistical methods. Number 4, you'll be able to identify various types of statistics. Number 5, you'll also be able to distinguish between statistical methods and educational statistics. And finally, under this module, you'll be able to appreciate the importance of data in your daily life. So stay tuned to the end of the video to be able to get all these concepts and information. If you are yet to subscribe to our channel, please subscribe and make a comment and like our videos so that you can get more of this content. So we'll start by saying that the nature, what is the concept of data and scientific observation? You see, the raw materials of all statistical work is data, whether you are looking at the enrollment figures in your schools, the number of participants from various states in national conference, or the number of successful candidates in public examinations, or salaries of teachers, or even in the voting system. We just did the election 2 years ago, and we saw how the parties fared. The data that came out from all those is the concept of statistical work. So the world is increasingly demanding for evidence to support decision making. So if you want to make decision, you just don't make decision based on sentiment. You make decision based on statistical data or facts, either that has happened before or you are actually projecting into the future using statistics. So in the sciences, all observations are presumed describable either quantitatively and qualitatively. So there are two ways: quantitatively, or qualitatively. Okay, so qualitative observation, such as gender classification, are sometimes represented by figures, such as 0 for male, 1 for female. So to make the record for easy access, so it's either a 0 or a 1. So just that there are two outcomes, you understand? So, but that is for qualitative. But quantitative has to do with actual numbers, okay, analysis. All right, so let's look at how an example of how data is used in our daily lives. Okay, so if, for instance, a restaurant prepared a menu for lunch for people attending a 2-day conference. So if at day 1 of that conference, they were able to get this kind of data, that 31 participants preferred jollof rice. So then they say 7 participants prefers eba, okay, and 18 participants prefer fried yam. Let me use yam. Fried yam, okay, or plantain. Some of us like plantain. Fried plantain or bole. Okay, so this is what is gotten. So you can actually put this kind of information in a statistical I mean, in a table, you understand, in a table. So I can come and say, I can come and say jollof rice. I can just put it like this, jollof rice. Just do a table like this quickly. I have eba, and I have the last one is fried yam and plantain. Okay, like this. So I'll just do a table like this. This is also, I'm just trying to build up. Then I can come here. I can put food or menu. I can put menu. I can put a number of participants. Okay, I'm trying to participants. Okay, I'm trying to represent what was gathered here. So this is what we call the raw data unprocessed. Now this one, now we are putting it in a way that when you look at it, you'll be able to work on it. So this is 31 for jollof rice, 7 for eba, and 18 for either fried yam and plantain. So this one is a very good way of representing. So the data, or the use of data, is persuasive. So we use data in our everyday life, although we do not always describe them as data. Note that for brevity, we can start to change it to A, B, or C. You understand? A, B, or C, and we'll define what it means with this kind of say A is for jollof rice, B is for eba, and C is for. So we can do that. So this is for day one. Now this table is not complete because it's not telling us the days that are involved. If, for instance, at the second day of the conference, we now have this. So I can come here and I put I change this one to day, and I say this is for day one. If at day 2 I now have another start coming like this, day 2, another start coming like this. So I now have another start coming like this. Let's say, for instance, now in day 2 I was presented with 21 taking jollof rice, and I was also told that 17 is eating eba, and 16 is eating fried yam. So I can have a column here for total. So let me just take this one off and put a column for total. So the data is now making sense. It's making sense. I'll put here as total. And by the time I sum up this is 16. By the time I sum up this, I can get the total for this as 54. And I can get the total of the day 1 as this is 31 plus 7 will give me 38. 38 plus 18. 38 plus 18. So will give me 56. So I have something like this. So from here, I can, if I'm a supervisor of that restaurant, I have the opportunity to have 2 sets of data for day 1 and day 2. I can see that jollof rice dropped from 31 to 21. I also see that eba increased from 7 to 17. Then this one also dropped from 18 to 16. Now the total consumption of the total people who ordered food dropped from 56 to 54. So I can begin to study why were they drop or increase, for any particular menu. Could it be that there were different sort of the people that came, or could it be the gender? Some people, men like eba more than women. Understand? So, and women like jollof rice more than men. Would it be that there were more women in this day 1? You could begin to make some inferences from the data sets. So, having known the use of data, you can see that data and organizing it, you understand, to tell a story is very important in our everyday life. Okay, so we're going to go into the purpose of statistics. Okay, so we have the purposes of statistics. on the board, you can see that statistics help us to, number one, present a large amount of quantitative information. So if, like, for instance, you just get so many raw data from the field, you went to gather data, you went to fill questionnaire, you see when you fill questionnaire, you see different information about numbers attached to a particular variable, a particular item, you understand? By the time you see the length of raw data that has been given to you, it will not make any meaning. It will not make any meaning for presentation. So what statistics does for us is that it helps us to present very large amount of data, present it in a way that it will look good for you to analyze. So you see quantitative numbers, you see numbers, and you see the items. Everything is presentable. Number two purpose is that it helps us to, in an organized way, go beyond meaningless records of school test results to a meaningful interpretation. That this school test result is just like an example of where it's been applied. So you can as well use it for where you just see results. You see so and so students score so and so score. You understand? You can see things like average. You can see things like the people in the first quartile or the second quarter or the inter-quarter range. When you talk about measures of central tendency or measures of dispersion, these are the things that you see when you are using statistics. So it helps, in an organized way, to go just beyond meaningless records, to meaningful interpretation. Third point is that it helps us to predict how likely an event will occur. So this is predictive. This is, in the future. It helps us to, predict how events will occur. Later, we will see the types of statistics where we see descriptive and you see inferential. So this is like an inferential kind of mode. Number four, it helps us to make inferences from observation. So from observation, by the time we look at your table, look at your data and statistics you are presenting, we can now infer. Infer means we can now say, based on what we are seeing, we can now say this, make some statements intelligently. Academicians don't just make statements out of sentiment or out of any. There must be a base for you to say that. There must be a collection of information that can make you to infer, can make you to deduce that, okay, this is this because of what we are seeing here. Finally, here, it says it helps us to save time and energy by condensing large amount of information concisely and conveniently into tables. So you see your data scattered. By the time you have table presentation, you see that everything is done clean and proper. So in addition to all this, there is hardly any discipline today, even in education, the arts or social science, that does not require some level of statistics. There's no place at all. So research reports in most disciplines are enriched by statistics. For you to now make a final inference, for you to now make a final conclusion, you will have gone through data collection, data presentation, and analysis, trending. Yes, and these are the things that I'm going to say in this course. Last one requirement for higher degree in most disciplines is that you carry out and do your own independent research. You see, so when you are doing your project, you know that you need to do your research. You need to infer from data. School managers are constantly faced with situations in which they have to make inference from observations. For instance, the proprietor of a private school took a week attendance and found some things. Things like class attendance, things like how many people came in primary one, how many students came on Monday or Tuesday, on Wednesday or Thursday, and when you finish everything, you do class average. You understand? So these kinds of things, even in education sector, will make you to project, make you to plan, make you to know, and ask questions. Why is it that attendance is reducing, or why is it increasing? All right. So we'll now move on to the next subtopic, the types of statistics. Okay, so we have the types of statistics on the board. So there are actually three classes of statistics. The first one is descriptive. Descriptive, from the word describe. So it refers to the manner of presentation of large amount of data. So how do you present data? It includes tools like average. So after I've given you all the data sets, for instance, I'll just give you the presentation. Average is this. Understand? Average, you have mean, median, mode. Percentages, you can present data by percentages. The number of young people of under 18 in the population, you present it in percentage. Understand? So this is descriptive. You are trying to describe the data using these tools. Charts can be used. Charts, graphs, and even if you go into IT, you see dashboard. You see different kinds of presentations to describe data. So the next type of statistics is correlation statistics, which allows you to examine patterns, compare groups, and predict future events from extrapolation. So that has to do with, you are looking at trend. You're looking at trend. So you see that, okay, the particular item or variable is going up, and there's a steady way of going up. Even if the data stop at a particular boundary, that means you did not go beyond a particular boundary. You can say, okay, since I didn't go beyond, I can say, if because the thing is increasing by 2 units in every one month, then I can say in the next so and so month it will increase by the number of units. Why? Because I see the one I have, the information I have, that this is how it's behaving. So with correlation, it allows you to draw, predict future events by extrapolation. The final one is inferential statistics. So you can draw by inference what's going on. So it allows you to draw out facts that are not immediately visible from the data. There are some things that data will not tell you, but because of the fact that you can see, you can draw facts. So it also involves making predictions or inferences about a large group of data based on smaller sample. It uses probability to estimate and to test hypotheses. Example. So you can try to estimate, estimating the outcome of an election based on a survey of 1,000 voters. Most of us did it then while we were doing the election in 2023. We had to do some. So some of them were not correct because of some influences, but then you see that many people came out with this kind of statistics, during the election. Okay. Okay, so we will conclude this lesson by looking at this tutor mark assignment, TMA. These questions are like the questions in the Unit 1 of this course that tries to summarize what we actually discussed. So the first question I have on the board is, what do you understand by the word statistics? So I say statistics is the branch of mathematics that deals with the collection, organization, analysis, interpretation, and presentation of data. Yes. So in simple terms, it helps us to make sense of numbers and information. For example, when you hear the word 70%, that's percentage. 70% of students pass an exam. That is statistics. That statistics is being used to summarize data in a meaningful way. So at least I can see that and say, okay, that's meaningful. Okay, so what are the purposes of statistics? The purposes for your study of statistics. The following are purposes. Number one, I can say that is to make informed decision. Statistics is used to make informed decision. It helps us to understand trends, relationships, patterns, which are very useful in our daily lives, in our businesses, and in our research. Second purpose of statistics is that it helps us to summarize and simplify data. You see the data that is so big and so clumsy, so untidy. So you can summarize it. Large amounts of data can be overwhelming. Very, very. Statistics helps us to organize data and to summarize it in tables, in charts, in averages, beautiful dashboards. Be able to appreciate it. Third purpose of statistics, yes, is to interpret and draw conclusions. It enables us to draw valid conclusions from data, such as making predictions or testing assumptions. And number 4 purpose is to support research and innovation. Okay, so like I said, academics, we don't just deal with emotions or sentiment or anything. In academic and scientific research, statistics is essential for analyzing experimental results and proving or disproving hypotheses. Third question here says, what are the types of statistics? I mentioned 3, but I'm going to be giving us 2 in this one. I like these 2. One is descriptive, second one is inferential. So descriptive deals with methods of organizing or summarizing data. It includes tools like averages. So inside average, you have mean, median, mode, measures of central dispersion. So you have percentages, you have graphs, you have charts, you understand, histogram, and so on. Example, like I said before, the average score in a class is 75%. That one is descriptive. I'm describing, the percentage of score of students. Second one type of statistics is inferential. In inferential statistics involves making predictions or inferences about a large group or a large group based on simple, smaller sample. It uses probability to estimate and to test hypotheses. That's inferential. So, like an example now I will give for this kind of statistics is estimating the outcome of an election. We did that again in 2023. Okay, so the last question here is briefly explain the word data in relation to statistics. So, statistics and data, as in what is data in statistics? So, in statistics, data refers to raw facts. Raw facts. I go to the market. I collect the price of item, the price of fruits, vegetables. Just collect them. Ask the sellers, how much is this? How much is that? How much is that? I write them in the paper, or I type them on my iPad. You understand? I bring them to my office. That data is raw. So it refers to raw data, numbers or information collected for analysis. See the word collected. That's why I said you go to market, you collect, you ask questions, you give this thing that we do. You give survey, papers for people to collect information. Collection of information is that word collect is actually needed in that definition. So it refers to raw facts, numbers, or information collected. Why are you collecting it? For the purpose of analysis. You're not just collecting it to keep it. You're collecting it to do further analysis. Data can be quantitative, that is numbers, numerical values, understand, height, price, weight, income, and so on. Or qualitative, non-numerical information like gender, male or female, understand, color, Roy GB, red, yellow, blue, and so on. Opinions, yes or no, understand. This is qualitative, and quantitative means numbers. So once data is collected, statistics helps in analyze and interpret it to get meaningful insights. For instance, data collected from the class can be a class test can be used to calculate the average score or identify students who need to improve or who needs academic support. So we'll stop here for today. I hope this video has been informative for you, and I'd like to thank you for viewing.